In this video, I'm going to explain you how to identify the addressing mode. So the question can be asked in the exam, write an addressing mode for the following instruction, and the set of instruction will be given. So the first instruction is move AX, BX. In 8086 microprocessor consists of 8-bit and 16-bit registers. So if one of the register will be there in our source operand as well as our destination operand, that time we are saying the addressing mode will be register addressing mode. So in the first example, AX and BX, these are the 16-bit registers are given in that source and destination operand. So this is our source and this one is our destination. So in case of source and destination, we have written the registers. That's why we are saying this is called as a register addressing mode. In the second example also, the instruction is division BX. So BX is our 16-bit register and this addressing mode is also called as register addressing mode. Now in the third example, the instruction is given like move num, AX. So num is the variable and whenever we are copying the contents of this AX register, that will be copied into the num variable. And here we are specifying the memory location for this num variable and the contents of our AX, suppose consider that it is 1000H. And whenever we are writing here move num, AX, contents of our 1000H that will be loaded into particular memory location and that is specified by this number variable. And this number variable consists of our memory location is equal to 0000. So for that location, our AX value will be loaded. So that this is called as a direct addressing mode. Now in the fourth example, the instruction is given like jump and AA. So jump is the instruction and we are writing here the AA, that is our label. So whenever we are writing the label in that particular instruction and we are writing here the jump label, that time we are specifying the addressing mode for our instruction is intra-segment direct addressing mode, because we are displacement of our address will be going to that particular label, that is AA label. As well as we can write for this addressing mode instruction is, suppose the instruction is given that is jump AA, we can also write the answer like direct addressing mode, because here we have not specified the particular address of that instruction. We are specifying the address for our label. And whenever we are writing here jump AA label, your control will be transferred to the particular label, that is AA. That is called as a direct addressing mode. So you can write any one of the answer in the exam. Now in the fifth example, subtract AX, 2000H. So here the 2000H, that is the immediate value of particular number and that we are giving with our AX register. So the operation will be subtract AX, 2000H. So AX is equal to AX minus 2000H. So the contents of our 2000H will be subtracted from our AX register. So whenever the immediate value will be given in that particular instruction, then we are saying this type of addressing mode is immediate addressing mode. Now the sixth example is, that is in AL, ATH. So here AL is the register and ATH is the immediate value. So we are loading that ATH memory location value into our AL register and in is our input output addressing mode. So whenever in the instruction in will be given, we are writing here input addressing mode. But whenever the out will be there in that instruction, we are writing output addressing mode. But here, what is the difference if the instruction is given as in AL, comma ATH? So ATH is the memory location, and that is directly given in that example. So this type of addressing mode will be direct input addressing mode. And you can check here in the next instruction in AL, comma DX, the register will be there. And whatever the contents of register will be there, suppose you can consider here 1000H. So 1000H value will be loaded into our AL register. But in case of instruction set, what is given in AL, comma DX. So whenever it will be given, you can write here indirect input addressing mode. So what is the difference between the sixth and the seventh example? In the sixth example, the value will be given, so that we are writing here direct input addressing mode. But in the seventh example, the location of that particular memory location will not be given. It is given in the form of register. So here the register is DX register. So that you can write here indirect input addressing mode. Now, in the in the eighth example, it's given. So these next two examples are given for output addressing mode, because out instruction will be given in that example. So see here in the eighth example, out AL, comma ATH. So ATH is the immediate value, and that we are loading into our AL register with the help of this output addressing mode. So whenever the value will be given in that instruction, we are writing it as direct output addressing mode. And here we have specified the register in that addressing mode. So that I am writing here indirect output addressing mode. Now in the next example, what is given? That is add AX, comma result. So result is the variable, and whenever we are writing here add AX, comma result, then we have to first of all identify what is the variable in that source operand. So in that source operand, the variable will be given, and in the destination operand, the register will be there. So how you can identify the addressing mode? If both are the register, then we can say that it is called as a register addressing mode. But whenever the registers are not there and instruction will be given in that example, that time we can say that as similar to our example, that is move num, comma x. Here is also one is the register and the second one is the variable. That time we have specified the direct addressing mode. So here also you can write the answer for this question like add AX, comma result variable, that is called as a direct addressing mode. The next example is CLC instruction, that is called as a clear carry flag. And here there is no operand will be there in that instruction. Whenever the no operand will be there in that particular instruction, that time we can write here implied addressing mode. Next example is move AX, comma SI. So here the index addressing mode will be there, because our index registers are SI and DI. So source index and the destination index, these two are the index register. If one of the register will be there in that particular instruction, so we can write it as index addressing mode. The The next example is move x comma BP plus 2. So here BP is the base register and we have two base registers, that is BP and next one is BX. So in the given example, BP is given. So we can write here the addressing mode for the instruction is base addressing mode. Now in the next example, add AL comma BX plus BX and DI. So here we have already seen that the base registers are BX and BP and our index registers are SI and DI. So here there is a combination of this BX register and the DI register. So whenever the combination of these both of the registers will be given in that example, so you can write the answer for this question, that is base index addressing mode. The next instruction is repeat load SB. So repeat is the string manipulation instruction and load SB is also string manipulation instruction. So whenever the string manipulation instructions are there in the example as the instruction set, then we can say that this type of addressing mode is string addressing mode. So whenever compare SB, then store SB, then compare SW, this type of string manipulation instructions are there in the example. You can write for this addressing mode is string addressing mode. Now the next example is move x comma bx plus si plus 2000. So here also we have to check the base register as well as index register. So in this example, bx is our base register. SI is our index register. So I'm writing here base index. But here the 2008 is the memory location that is loaded into SI and the BX register. So whenever the contents of memory location is also given, so that we are writing here relative base index addressing mode. For this type of addressing mode also, you can write the answer like base index with displacement mode. So you can write any one of the answer in the example when this type of question can be asked. So in this next example also, move cx comma bp plus di plus 5. This value is given. So bp is the base register, di is the index register, and our 5 is the immediate value. So I'm writing here relative base index addressing mode. And you can also write the answer for this question as base index with displacement mode. So in this way, you can identify whenever the instruction will be given in the exam. So you can write down what is the addressing mode for the particular instruction. And this type of question can be asked for 5 marks in the university exam question paper. For the detailed description of identification of our addressing mode. Each and every addressing mode will be explained in detail, and the link for the video is given in the description box.